All right, everybody, welcome to Unit 9. And this is a really important chapter in which we actually do a lot of real deal statistics. This is going to be a thing called hypothesis testing. And what hypothesis testing is something like this. There's a lot of different symbols and things like that that you're going to be introduced to. The first one is H with a little subscript 0. It's called H naught. And from here, you're going to see the average is equal to, 7 or something like that. Now, what mu is the population average. It's what the average really is. All right, really is. So mu is like historical. So in the past, this has been the average. All right, so in the past, this has been the average. And then right now, you're doing the present. All right, and this is a sample. All right, so this is like our investigation. And so what we do is we see, oh, our average is 7.3 or something like that. All right, so H1 is what do you think is happening to this historical average? Should it be 7? Should it be bigger than 7? Should it be less than 7? Should it not be equal to 7? And so if I see that the present is 7.3, I think the average should be bigger. All right? And so this is called your null hypothesis. And this is called your alternate hypothesis. All right, so what we're going to do is we are going to accept this as the answer. But then we're going to do a whole bunch of statistics. And if our statistics are strong enough, and our sample is strong enough, then we can say, no, this is not true. Rather, this is true. If we have enough evidence. If we have enough evidence, we can say something else. And so what we're going to be learning is, like, how do I make that evidence? How do I do the statistics to reject some average that you might think about that has always been accepted as true, and you might accept something else. Okay, again, there's not a whole lot of actual math in these problems. What you're going to be graded on and what is going to be studied is how you show your work, what work do you show, are you showing the proper evidence, and are you saying things correctly? So my advice to you is copy down these exact examples. How I do a problem is how you should be doing the problem. Like, we can talk about, like, I do it a different way. We can have all those conversations later when you have a math degree. All right. For right now, you just kind of have to follow along. And I hate that excuse and I hate those statements. But for right now, let's learn the process, and then eventually you can learn how to manipulate the process. Okay. So number 1. It says the Arizona Match Company sells matchboxes that are supposed to have an average of 40 matches per box. So that's the historical average. The average is supposed to be 40 with a standard deviation of 9. A random sample. So our sample average of 94 matchboxes, that was our sample size, shows an average to be 42.2. Using a 1% level of significance. This is the symbol of alpha. It looks like a fish. 1%. All right? And the question is, are the boxes now more than 40? That's the question. Okay, so the first thing that we need to do is we need to state our null and alternate hypotheses and the level of significance, and then say, is this a left tail, right tail, or two tail? All right, so the null hypothesis is what we're accepting as the historical average. So the average is equal to 40. And the alternate hypothesis is always going to look exactly the same. So mu is mu, 40 is 40. However, we're going to come up with a different symbol that goes in the middle there. And what that symbol is dependent upon the question. We want to know, is it now more than 40? So is our average now greater than 40? The level of significance is our alpha. So this is our level of significance is going to be 1%. And so writing that as a decimal, that's 0.01. And then is this a left tail, right tail, or two tail? For right now, for simplicity's sake, take a look at the inequality that is on the alternate hypothesis and think of it as an arrow. What direction does that point? It points to the right. This is going to be right tail. Okay, so think of the inequality as an arrow. All right, next question. Identify the appropriate sampling distribution, the standard normal or student's t. What is the value of the sample test statistic? Okay, here's the one math problem that is in here. Okay, so the first thing that we need to know is this a standard normal? If it's a standard normal, aka you're talking about this is a z. Okay, this is a z. Okay, and if it's a student's t, that's in other words saying that it will be a t. So, and again, the ultimate difference is, do you use your z table or do you use your t table in finding your value here? All right. And to answer this question, z's are going to be when you have sigmas or probabilities. T's are when you have sample standard deviations, S's. Here we have a sigma, so this is going to be a z. So the first answer to this question is this is going to be a standard normal. Okay, so that means we're running with a z. So a z with a sigma. So this is going to be z is equal to x bar minus mu divided by sigma divided by the square root of n. Let me quadruple check that. I'm 95% sure, right? Yeah, sigma divided by the square root of n. Very well. Okay. And so from here, I don't need you to write in the numbers. However, my advice is put this top piece in a parentheses and this bottom piece in a parentheses when you enter this into your calculator. That's my advice to you. So how I would do this, I would take x bar minus mu in a parentheses divided by sigma divided by the square root of n in a parentheses. So this is a z-score, so that goes to 2 decimals, so that's 2.37. Okay, now this is one of the most important questions on helping us determine what our answer is. It first asks us, find or estimate the p-value, and then sketch a sampling distribution that shows the areas corresponding to the p-value. All right, so the first thing that we do is we find this quote-unquote p-value. And this is going to be built upon the answer that you just got in the previous question, whether it be a Z or a T or whatever it is, that's what your p-value is going to be based on. So this is a Z of 2.37. Now, I'm not going to get into it like in this video right here. I can explain myself, but I don't want to overwhelm people with thoughts. But this Z value, always look up as a negative. If it's a negative, cool, keep it a negative. If it's a positive, like it is here, look it up as a negative on your Z table. So I go to my Z table and I got 2.37. So onto the Z table. I need to look up 2.37, but as I said, always look it up as a negative. So negative 2.37. Negative 2.37. Always look it up as a negative. If it's already a negative, cool, keep it a negative. If it's a positive, look it up as a negative. And again, I don't want to overwhelm you with the reason why right now, but just do it. Oh, totally missed the value. I'm sorry. 0089. Okay, remember that. 0089. Okay. Now this sketch. So what we're going to do is we're going to sketch a distribution. Okay. And now there's several different things that we're going to be putting on here. First and foremost, that this is a right tail. So I create what I call the rejection zone. I make this line on the right-hand side of my graph because it's a right tail. That's where the rejection zone goes. And I make a vertical line, and I kind of make these side slashy marks. Okay? This is what I call the rejection zone. That's the rejection zone. And then physically what I write in the not rejection zone is do not reject H naught. Do not reject H naught. I physically write that in the picture. All right. What this edge is, the level of this edge is alpha, and alpha is 0.01. 0.01. I'll extend it by a couple decimals. 0.01. Okay. Now, what the heck, why, and what, huh? Is probably a good question. All right. What I want you to think about when you look at this picture down here is think of this, like 0.01 of alpha, as a distance from the edge. As a distance from the edge. And that distance from the edge is 0.01. All right, 0.01. Now, if I were to put my p-value, which has a p-value of 0.0089, okay, from the edge, same idea, would it be bigger than or smaller than the alpha? Like, would the distance be large enough to get over here to fall in this do not reject zone? Or is it too short and falls into this rejection zone? That's the question, and that's what you have to do to be able to decipher this problem. And so thinking of it as a distance from the edge, I see that 0.0089 is smaller than 0.01, so its distance is shorter, thus the p-value, I make a dark line, falls right there. It falls short. It falls in the rejection zone. All right. So next it asks me to compare the p-value to the level of significance and draw a conclusion. All right, so here we go. This has to be one of two different ways. Here's the one of two different ways. The way that this problem goes is this. The p-value is less than alpha. What does that mean? Well, that falls in the rejection zone. So we reject H naught and accept H1. Do not use your own words. As I said, you should be copying my work exactly. This has to be exactly that answer right there. Don't change the order. Don't say it differently. Don't abbreviate things. Say exactly that. The other potential answer that you could potentially get, like in a different world, is that the p-value is greater than alpha. Okay? The p-value is greater than alpha. So what do we say? We do not reject H naught. Okay, that's the alternate world. Don't say we accept something, just say do not reject H naught, and ta-da, you're done with that statement. And we'll obviously see examples of these in future problems. Okay, on with the show. Interpret your conclusion in the context of the application. All right, so when I reject H naught and accept H1, that's exactly what I'm going to say. However, H naught, go back to what you wrote for H naught and just interpret your symbols. Right, so this is the average. Is equal to 40. All right, so I'm just going to interpret my conclusions. And so here, this is again the average is greater than 40. All right, so all I'm going to do is I'm going to interpret this, okay, and then add a little context. So well, I'm first going to say we reject H naught. So we reject H naught. So that is going to be the average okay, and here's where I add the context, aka what is the story talking about? What is our averages of? And this is matches per box. All right, so again, H naught is saying mu is equal to 40. So we have the average, matches per box, is equal to 40. We reject H naught. And H1, what we have written above, is this. And so that's what we say. So we reject H naught and accept the average. I don't have to add the context twice. I already described what the average, quote unquote, is. The average is greater than 40. Okay, last but not least, and I would be a bad teacher if I didn't explain the alternate universe. Again, what would happen if this was my conclusion? Do not reject H naught. What do we say in that situation? So when we do not reject H naught, what we say is we do not have enough evidence to say, and then what we say is, in essence, H1. Then we say we do not have enough evidence to say H1. And H1 is the average matches per box is greater than 40. We don't say anything about H naught, okay? It's just we do not have enough evidence to say H1. That's what we'd say in that alternate world. When we reject H naught and accept H1, that's exactly what we say. We reject H naught and accept H1. And then when we do not reject H naught, that means we do not have enough evidence to say H1. Okay. So let's kind of put it together a little bit more. So it says long-term mean daily sales were 24,819. That's the history. They should be 24,819. A sample of 40 days, our sample size is 40. During a new ad campaign gave a sample mean. Our sample was 25,652. It's gone up. Does this indicate that the population mean is now more than 24,819? That's the question. Use a 1% level of significance and assume that the standard deviation, notice how it's a sigma, is 1917. Okay, first question is the null and alternate hypotheses level significance and left, right, or to tail. All right, so our null hypothesis is what history is showing right now, that the average is equal to 24,819. Our alternate hypothesis looks identical to that, except we have to decide what symbol goes in the middle. And I see that 24,819 is going up to 25,652. So I think the average is actually bigger than that 24. I think it's now more than 24. The level of significance in this case is 1%, which means 0.01. And looking at the arrow of my inequality, it's pointing to the right. So this is a right tail. All right, because this has a sigma in the question, this is going to be a standard normal. Meaning that we're going to be getting a z-score, which is x bar minus mu of sigma divided by the root of n. Again, put a parentheses around the numerator and around the denominator. So parentheses around x bar minus mu. Divided by and numerator around the denominator. .75. From here, we create our p-value. Our p-value is directly related to the answer that we just got, which was a z of 2.75. Always look that up as a negative. So I look up negative 2.75. Zero, zero, 3, 0. Okay, I make my picture. This is a right tail. and this is an alpha. Alpha in this case is 0.01. Looking at my p-value, again, think of this as a distance from the edge. This is 0.01. Okay, this next one has 0.003. So it falls short. This is where our p-value stops. Okay, think of it as a distance from the edge. What does that mean? That means that the p-value is less than the alpha, thus I reject H naught. And if I reject H naught, that means I have to accept H1. When this is my conclusion, this is exactly what I have to say. Again, just as a reminder, H naught said that the average is equal to 24,819. And then the alternate said that the average is greater than 24,819. I think these are daily sales. Okay, that's what the context is. All right, so interpret this conclusion. We reject H naught. We reject. And so H naught is the average is equal to 24,819. So we reject that the average daily sales okay, so we reject that the average is equal to 24,819 and accept the average is greater than 24,819. So again, that last question is just literally interpreting symbols. Take things out of math speak and say them as like a normal human. Okay, that will get you started. Again, this first example, I spoke a lot about like different ways of doing things and things like that. Again, this is confusing. And my advice to you is practice, practice, practice. You have to write everything out perfectly. Do not put your own interesting spin on it. Don't say things your own unique way. Don't say the word equals. Don't say bigger than. Don't say better than. You have to stick to the math words like is greater than, is equal to, is not equal to, is less than, those sort of words. Yeah, and so it has to be exactly this way. So the more practice you get, the more comfortable you're going to be able to feel, and the more successful you'll ultimately be. So again, practice, practice, practice. Practice writing this stuff. Practice drawing the picture. Things like that.